All right, now I'm going to get through the last two together problems for chapter 10, number 88 and number 90. Now, I didn't get a chance to scan in the picture, so I did my best to draw a picture of the problem for chapter for number 88. It's in the book, and it says sulfur exhibits two solid phases. Okay, it has rhombic and it has monoclinic. So that's why we have both of these. Oops. Um, both monoclinic here and rhombic. So these are essentially two solid phases. Then we've got our liquid here and we've got our gas. So we still have phase diagrams. The only thing that's different is that we've got two solid phases that are going to exist. And it's going to want us to answer a few different questions. Says use the accompanying phase diagram for sulfur to answer the following questions. Phase diagram is not to scale. Clearly, we've got pressure on the y-axis. We go all the way from 5.1 times 10 to the negative sixth, all the way up to 1,420 atm. So it's not to scale, but we can still discern the important information. Okay, letter A. See if I can answer them all out to the side here. How many triple points are there? The answer is 2. Okay, remember, a triple point is where 3 lines um, essentially are going to come together, and we have one here and we have one here. Okay, so that's where our two triple points right here and right there, if you have a tough time seeing that. So we got two triple points that we're going to have, okay, on these graphs. Letter B, what phases are in equilibrium at each of the triple points? If we call this one number 1 and this one number 2, okay, on the first one, okay, the one that's at 95.31 degrees Celsius, the three that we will have are rhombic, monoclinic, and gas. Okay, so those are the three, which really is just what three things come together at that spot. And then for number 2, so that's the first one. Then for number 2, which is going to be right here, the three phases that we're going to have at 115.18 are going to be monoclinic, liquid, and gas. And actually we do have a third one. I'm sorry, I forgot about this one up here. We also have a third one up here. Okay, here's our third triple point, and at our third point, the three phases that we have present are going to be monoclinic, rhombic, and liquid. Wow, this is why I type stuff, isn't it? Okay, so anyway, those are the triple points, okay? So we've got 3 of them, so I'm sorry. That should be 3 triple points and not 2. Heaven forbid I get it right the first time on the first try. Okay, from the next one that we have to ask is what is the stable phase at 1 atm and 100 degrees Celsius? Although we got a lot of writing on here, it's no different than just following the graph. Now 1 atm is this dotted line that's right smack in the middle. That's general, normal, typical air pressure. So if we've got 1 atm, 100 degrees Celsius has got to be somewhere in the middle here because this is 95.31 degrees Celsius. No, I don't want to change that. Don't show me this message. This is 95.31 degrees Celsius. This is 115.18. So it's got to be in the middle here. And it doesn't matter where because all it's asking us is what phase is present. So for letter C, on this one, it's going to be the monoclinic, probably, well, no, phase that is stable just by reading the graph, okay? And then letter D, what are the normal melting point and the normal boiling point of sulfur? That's when you're looking at going into the liquid phase, entering the liquid phase, and entering the boiling point, or excuse me, entering the gaseous phase. And so for the melting point, this is the barrier of where we're going from a solid to a liquid. So my melting point is going to be 115.21 degrees Celsius. Okay, and then if we continue on that 1 atm, the picture in the book's easier to follow, but I kind of had to do the best I could. So then if I follow it along here, the next temperature that we have right here is going to be 444.6 degrees Celsius. And so that's going to be our normal, typical boiling point simply because it happens right at that 1 atm level. Okay, so those are going to be our melting points and our boiling points. And then for letter E, we want to know what is the densest phase. And remember, for these, typically whenever you have a positive slope between the solid to the liquid, that's a typical trend, meaning that the solid, where am I here? The solid is going to be the densest phase. One of the only exceptions that has a negative slope is water, and that's because ice is less dense than liquid water. That's why it will float on top. But based on the fact that this has a positive slope, the solid is going to be more dense. And then for letter F, it wants to know, is it possible for the rhombic sulfur to sublime, which means we're going to go directly from a solid to a gas at a pressure of 1.0 times 10 to the negative fifth atm. Can it completely sublime? Okay, now if we look at where that pressure is, it's got to be somewhere in the middle here. Okay, so it doesn't necessarily matter where it is, but since it's somewhere in the middle here, and that's the border for monoclinic right to gas, the answer is going to be no. Okay, so when you're trying to decide if something can sublime, it's can it get into an area where you're going to be able to go directly from a solid to a gaseous phase, which it could do right here for monoclinic, but that's not in the range for it to happen for rhombic. And then lastly for letter G, and this is a pretty common question, it may give you a course to follow on the graph. Let me see here, there we go. And it wants you to describe the phase changes. So it says what phase changes occur when the pressure on a sample of sulfur at 100 degrees Celsius. So we're going to be somewhere in here on our x-axis because that's temperature. Okay, 100 degrees Celsius is increased from 1.0 times 10 to the negative 8th. So we're going to start somewhere, let me find a different color here. Let's use bright pink. All right, we're going to start somewhere in this region here. Okay? And from 1.0 times 10 to the negative 8th all the way up to 1500. Okay, so basically we just have to describe the phase changes. So the phase changes would go like this. We would start off with gaseous sulfur. Gaseous, right? Because it's in the gas phase. After we, at 100 degrees Celsius and somewhere around times 10 to the negative fifth, somewhere in there, we would go to the solid monoclinic, which that would be deposition because we're going directly from a gas to a solid. Okay, finally at 100 degrees Celsius and somewhere around, after we go through monoclinic, and my diagram's even tougher to say, but some pressure that's less than that 1420, that top range that they gave us, we would go from monoclinic and we would go to rhombic. So it's really just being able to follow a path on the phase diagram and answer the questions. And the only reason this one is that different is simply because it had two solids instead of one.